All right, welcome to section 2.4, part 1. We're going to start talking about zeros of polynomials. And just remember, zeros means other things. It means roots, it means solutions, and it also means x-intercepts. Okay, so all of those things mean the same thing. So don't forget, if it asks for zeros, it means roots, it means solutions, it means x-intercepts, all the same stuff. All right, so our essential question, what we're trying to solve is, what are the best ways to find all zeros of a polynomial, both real and imaginary? Okay. In this particular video, all we're going to worry about are we're going to find the real ones, the real numbers, no imaginary numbers. All right. So it says polynomials can have n real zeros when n is the degree of the polynomial. So each of these, the highest exponent is 2. So each of these can have 2 real zeros. 2 real zeros. Okay, so let's find them. Okay, this one can be factored. There's 3 terms here, so we can factor it. So 3x minus 2 and x plus 3. I'm not going to worry about showing how to do that, but this is the factored form. So this one has an answer of positive 2/3. You add 2, divide by 3. And this one, you just subtract 3, so it has an answer of negative 3. So that one has my 2 zeros. They're both real. This one has only 2 terms, so I can just solve for x. So if I add 5, x squared equals 5, take the square root, x is equal to plus or minus root 5. All right, so that one also has 2 answers. As soon as I take the square root, I got to do positive and negative. So what does this all mean? So if I look at my graph of the original equation, the graph, 2/3 and negative 3 were my solutions. Well, where does this graph cross the x-axis? This one's at negative 3, and this one's at 2/3. There are my roots. There are my zeros. This one crosses at plus or minus root 5. Well, root 5 is a little bit above 2 point something. So there's positive root 5, and then there is my negative root 5. Okay, so if you find the zeros, that means you found the x-intercepts. Okay, put those two things together. All right, so what we have here is called the rational zero theorem. In Algebra 2, last year in our old books, I believe we called it the rational root theorem. Okay, all the rational root theorem does is it describes how the leading coefficient and the constant terms can determine a list of possible real zeros. Not all the actual answers. All it's going to do is give us a list of the possible real zeros. All right, so here's a big fancy definition. All we really need from this is that P are the factors of the constant, and Q are the factors of the leading coefficient. Okay, so that's all we really need from this. Okay, so let's see how this works. It says list all the possible rational zeros. Okay, that's part 1. So what we need to do is we need to find our P's and we need to find our Q's. All right, so P's are the factors of our constant, and Q are the factors, I'll do this one in red, are the factors of our leading coefficient. Now, we have no number there, so we're going to assume it's a 1. So what are the factors of 1 and 1? Well, that just is 1 and negative 1. So both of these happen to be 1 and negative 1. Now, these are going to help us get our list of possibles. Our possibles are our P's divided by our Q's. Okay, so positive 1 and negative 1 divided by positive 1 and negative 1 are just positive 1 and negative 1. So this is very simple because they're just 1s. Okay, so now, here's our possible list. These are the only numbers that are possible zeros of this problem. All right. So the second part of the question says, then determine which of these are zeros. Okay. So let's start with 1. So we're going to put 1 in the box, and we're going to do our coefficients. I want to get rid of this so we can see our problem a little nicer. All right. So we just set up our synthetic division problem. So our coefficients are 1. I'm missing my x squared, so I need a 0. I have a 2, and I have a 1. Okay, so let's see if this works. Bring down the 1, multiply, I get 1, add, I get 1, multiply, I get 1, add, I get 3, multiply, I get 3, add, I get 4. So this number has to equal 0. It doesn't, so 1 is not a 0. Okay, so I can cross off 1. Now I'm going to try negative 1. Same thing. Okay, 1, 0, 2, and 1. And we're going to see if our number at the bottom, our remainder, is a 0. Bring down the 1. Multiply, I get negative 1, add, I get negative 1, multiply, I get 1, add, I get 3, multiply, I get negative 3, add, I get negative 2. Okay, is this number 0? No, it's not. Negative 1 is not a 0. So none of these numbers are real zeros. So if none of these are real, they have to be imaginary, and we're not going to learn how to do that yet. Okay, so this one doesn't have any real zeros. All right, let's go to example 2. Okay, same exact definition. All right, so we're going to find our p's, we're going to find our q's. So our p's are all of the factors of 9. So 1 is a factor of 9, 3 is a factor of 9, and 9 is a factor of 9. No other numbers are factors of 9. Q's are our factors of our leading coefficient, which is 1. So the only factors of 1 are 1 and negative 1. Okay, our list of our possibles, is P divided by Q. Okay, so we're going to take all of our P's and we're going to divide it by all of our Q's. So 1 divided by 1 is just 1, so plus or minus 1. 3 divided by 1 is 3. And 9 divided by 1 is 9. Okay, so here are the only possible real zeros for this particular problem. Okay, so second part of the question says then determine which ones are zeros. So that's what we're going to try. Okay, so we're going to try 1. We always start with the lower numbers. So we're going to try 1 here. Our coefficients are 1, 4, 0, negative 12, negative 9. Okay, we're going to see which one works. Bring down the 1, multiply, I get 1, add, I get 5, multiply, I get 5, add, I get 5, multiply, I get 5, negative 7, negative 7, negative 16. Okay, definitely does not work. I can cross off 1. 1 does not work. Okay, so I'm going to go to the next one. Let's try negative 1. Okay, same coefficients, 1, 4, 0, negative 12, negative 9. This is a little tedious, so don't get impatient. Bring down the 1, multiply, I get negative 1, add, I get 3, negative 3, add, I get negative 3, 3, negative 8, oops, sorry, negative 9. Oops, let me get rid of that. So let me start again here, negative 3, 3, negative 9, multiply, I get positive 9, add them together, I get 0. Okay, so negative 1 is one of my zeros. Okay, I'm going to keep that one. I'm going to circle it. All right, so I now know that x plus 1 is one of my factors. Okay, now I'm going to also, I can now use these. I've gotten rid of my original, and now I have a lower set of numbers here. So what I'm going to do is I'm now going to find one. My goal is to get it down to an x squared so I can factor it. So 1 and negative 1, now I'm going to try 3. Okay, so now I'm going to try 3 with my new set of coefficients because I already know negative 1 works. Now I got to go to my next set of numbers, so I'm going to try 3. So 1, 3, negative 3, negative 9. Okay, so we're going to see if this works. Okay, so 1, multiply, I get 3, 6, 18, 15, 45. If I add these together, it's definitely not equal to 0, so 3 does not work. Okay, so I can cross off 3 from my list. The next number on my list would be negative 3. So now I'm going to try negative 3 using these coefficients because that's what I've broken it down to. So 1, 3, negative 3, negative 9. So let's see if this works. 1, negative 3, 0, 0, negative 3, 9, negative 9 plus 9 is 0. So now what have I done? I've gotten another factor. So now another factor is going to be, if this is negative 3, x plus 3. Okay, and now what's left over? So here's where we have to think. We started with an x to the 4th. So my first one that works is going to drop down to an x to the 3rd. And the second one that works is going to drop us down to an x to the 2nd. So as soon as you get to an x to the 2nd, you can stop because you should be able to solve that one. So I have 1x to the 2nd plus 0x minus 3. Okay, I don't really need that minus 0x, so I'm going to get rid of it. All right, so I'm basically left with x squared minus 3. So I have 1x squared, oops, 1x squared minus 3. All right, so what I have to do now is I have to finish my problem. Okay, so I know I have one answer, which is negative 1. I know I have one answer, which is negative 3. And now this one I need to set equal to 0 and solve. X squared minus 3 equals 0. Add 3, x squared equals 3, square root, x is equal to plus or minus root 3. So I have positive negative 1, negative 3, and plus or minus root 3. Okay, and there are my 4 answers. Now, it's pretty tough, I know. It takes a long time, but I think you can handle it. All right? So, let's move on to the last one that we'll worry about. It says list all possible rational zeros, okay, and then determine which ones are zeros. Okay, so let's find our p's and q's. Okay, remember, p's are the factors of 8. Factors of 8 are 1, 2, 4, not 6, not 7. 8 is a factor of 8. Now we need q's. Remember, q's are the factors of your leading coefficient. Plus or minus 1, plus or minus 3. Okay, so now what we need is that we need our actual list of possibles, our rationals, ones that can be written as fractions. So we have p divided by q's. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. So I've done all my 1s. Now I'm going to do the 3. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. And 8 divided by 3 is 8/3. So here is my list of all possible rational real roots. Okay, these are the ones that can be written as fractions. So how do I start the problem now to determine which ones are zeros? All right, so this is a long process, so I'm not going to give you a ton of these, but you need to start with 1. Okay, do your coefficients, so 3, -7, -22, 8. Okay, I'm going to tell you right now that this one does not work. Okay, 1 does not work. I'm going to tell you right now that -1 doesn't work. Okay, I'm going to tell you right now that 2 doesn't work. Okay, so let's try -2. All right, so let's try -2. Let me use a different color here. So we're going to try -2. We're going to see if this one works. 3, -7, -22, 8. All right, so let's see. Bring down the 3, multiply, I get -6. Okay, I get -13. I get 26, multiply 26, add, I get 4, multiply, I get -8, add, I get 0. Okay, so what have I done? I know that -2 works. So x plus 2 is one of my factors. And then what do I have left over? So notice up at the top, this was an x cubed. So now I'm already at an x squared now. So my coefficients are 3x squared minus 13x plus 4. Okay, so what do we do now? We just factor the remaining problem. So this one's already factored, x plus 2. And I'm not going to spend the time to show you how to factor this. This factors to 3x minus 1 and x minus 4. You should be able to do this. So what are my answers? Okay, so my answers are -2, add 1, divide by 3, so 1/3, add 4, I get 4. So I have my 3 answers. Okay, so your goal is to get it down to an x squared and then factor. All right, so there's 2 examples left, example 4 and the story problem. We will do those, but this should actually be example 5 because this is 4. We'll do the rest of those in class. Have a good night, and I will see you tomorrow.